Hello everyone, and welcome to the Solutions lecture for the Decision Trees and Random Forest project. In this lecture, we'll go ahead and work through the code for the solutions. Let's go ahead and jump to a notebook to get started. Alright, here I am at the project notebook. I'm going to go ahead and just scroll down to get started. First thing we need to do is import the usual libraries. I'm going to import pandas as PD and import numpy as np. And then I'll do my visualization libraries, such as matplotlib.pyplot as plt, and importing seaborn as SNS. And then finally, since I'm in the notebook, I'm going to do matplotlib inline so I can see my visualizations. Then we want to use pandas to read in the loan data.csv file into a data frame called loans. I'll go ahead and say pd read csv, just using tab there, and then start typing out loan, and I should see loan underscore data as a CSV. Let's go ahead and check out the info, head, and describe methods on the loan. So checking out loans info, we go ahead and see that there's around a little less than 10,000 rows and there's 14 columns. And if you want more information about what these columns represent, you can just come up here and read out these column descriptions. But we'll go ahead and continue on with the describe method. You can see loans describe to get some statistical information off the numerical columns. And then finally, if you just want to see what a typical column looks like, you can just call loans head and pass in some rows. So you can see there's a credit policy, purpose, the rate, installment, etc., FICO score, and then some more information. Now we're going to go ahead and move on to some exploratory data analysis. We'll go ahead and start with some data visualization. We're going to use Seaborn and Panda's built-in plotting capabilities, but you can also feel free to use whatever library you want that we covered in the data visualization section of this course. And one more note, don't worry about the colors matching here, just worry about getting the main idea of the plot. First thing we wanted to do was create a histogram of the two FICO distributions on top of each other, one for each credit.policy outcome. First thing we want to do is check out the example plot here. Looks like we have a histogram of the FICO score, and then you have blue equals credit policy equals 1, and then the red is credit policy equals 0. That means we're going to have to separate by credit policy. I'm going to do this with Panda's built-in histogram. I will say loans where this credit.policy is equal to 1. And I'm going to go ahead and copy and paste that where credit policy is equal to 0. And then off of both of these, I'm going to grab the FICO column. And then I'm going to just call .hist off of this. You can also do .plot.hist, but either way it should work. And then we will go ahead and do a couple more things. If we just do this, let me go ahead and run this, show you what this looks like. We get a plot that looks like this, which is okay, but we want a little more information here. Let's go ahead and increase the bins. So let's go ahead and say 35 each. So bins equals 35. And then we want to color them if we want to say blue for an actual credit policy and then red for not a credit policy. And I'm going to go ahead and add in a label. And that way we can call PLT legend at the end of this. If I just say PLT legend. This one is credit policy equals 0, so I'm going to go ahead and say that. Credit policy equals 0. And then I'm going to do a similar thing up here, so I can just copy and paste this line, except this is credit policy equal to 1. And I'm going to break this up so it's in another line, so we can actually read it a little easier. All right. And then finally, I want to add in an alpha to this. So I'm going to go ahead and say alpha equals 0.6, just so there's some clarity of how see-through this is. So alpha is equal to 0.6. And then let me go ahead and expand the figure size a little larger by saying PLT figure, fig size is equal to 10 by 6. All right, let's see if all this worked. Great, and now we have a really nice looking visualization where I can very quickly see a lot of information about the data. Right off the bat, I can tell that I have more people in my data set that have a credit policy equal to 1, then a credit policy equal to 0. And I can also see that based off of the FICO score, we can add that label in. So we'll say PLT X label is the FICO score. That based off of this FICO score, people who tend to have a lower FICO score have a credit policy of 0. And remember that credit policy 1 is if the customer meets the credit underwriting criteria of lendingclub.com, and it's a 0 if otherwise. We want to go ahead and check this out by looking at this cutoff point. And you can see that basically anyone with a FICO score of less than around 660 will automatically not meet the credit underwriting criteria of lendingclub.com. So that's an interesting visualization to get some information off of your data set. Let's go ahead and create a similar figure, except this time by the not fully paid column. So not fully paid equals 1, not fully paid equals 0, which is again what we're trying to predict. I'm going to go ahead and copy this, because essentially all we have to change is instead of credit policy, we want not fully paid. And I can just use tab autocomplete there. So not and then tab, and we'll go ahead and say instead of credit policy equal 1, not fully paid. And again here, we'll change this to not fully paid. And let's go ahead and run that. And here again we can see that the majority of people have 0 for not fully paid, meaning the majority of people are actually fully paying off these loans. And we can see that more or less there's a similar distribution between both not fully paid equals 1 and not fully paid equals 0. Doesn't seem to have the same sharp cutoff on FICO score as the previous credit policy did. You can see that these essentially overlap. The only difference is the actual counts. And you'll notice that there's kind of weird spikes at certain points, and that's just because of the way FICO credit scoring works, that certain points will have a larger distribution of likelihood of being your FICO score. Now let's move along by creating a count plot using Seaborn showing the counts of loan by purpose, with the color hue defined by not fully paid. Alright, in order to do this, I need to call sns.countPlot. If I look at the example plot here, I want X to be purpose and the hue to be not fully paid. So I'm going to say X is equal to purpose. Whoops, my hue is equal to the not.fully.paid column. My data source is loans, that's my data frame. And I'm going to go ahead and set the palette equal to set 1, just so I can get this blue-red palette continuously. And here's my plot. I'm going to go ahead and increase the plot size, the figure size, using PLT figure, fig size, and then if we make it 11 by 7, we won't get this kind of weird overlap on those labels. Great. So just by looking at this plot, we can tell that debt consolidation seems to be the most popular reason for wanting a loan. And then credit card and all other reasons are second and third place, with things such as home improvement, small business, major purchase, and educational reasons being much lower on that list. Something to note here is that the ratio between not fully paid and fully paid seems to be pretty similar between all the reasons. Let's go ahead and continue on by seeing the trend between FICO score and interest rate. So we're going to recreate this following joint plot. And you can see here that as your FICO score increases, the interest rate you have to pay off that loan tends to decrease, which kind of makes sense. Let's go ahead and see how we can do that. We'll say sns.jointPlot. X is FICO, and we'll set Y is interest rate, which is int.rate. We'll set data to the loans data frame, and then I'm going to say color is equal to purple, or you can just use the default color. And here we were able to recreate this plot. And this makes sense that as your FICO score decreases, it means as your FICO score increases, you have better credit, so your interest rate on your loans is probably going to go lower, and vice versa. As your FICO score goes down, you have worse credit, so your interest rate you're going to have to pay off that loan is going to go up. Now what we want to do is create the following LM plots to see if the trend differed between not fully paid and credit policy. And again, you can check the documentation for LM plot if you can't figure out how to separate this between two columns, but let me go ahead and show you how we can do that. We say sns.lmplot. We need to first say what we want on the y. So if we look at the y, that's just going to be the interest rate, INT rate. And if we look at x, we want that to be the FICO score. And our data is going to be equal to loans. If we just take a look at this plot by itself, we get something that looks like this, which is essentially the plot up here, just with a linear model line on top of it. However, we want to go ahead and add a couple more arguments here. I want the hue to be defined by their credit policy column. If we go ahead and check that, now we have credit policy 0 and 1, and again we notice that kind of cutoff around the 650 mark. And then the second thing I want to do is actually split this up into two columns, and you can do that by passing in the call arguments, COL. And I will say COL is equal to not.fully.paid, and I will set my palette equal to set1, just so it matches some of the previous things we've done. And I'm going to go ahead and expand the figure size by saying fig size is equal to 11.7. And now we're going to get a plot that matches what we wanted for the output. So here we have the columns representing the not fully paid value and the coloring representing the credit policy. And you can see here that the behavior is relatively the same whether or not it was fully paid off or on, and whether or not they were denied the credit policy. We'll go ahead and stop part 1 of the solutions lecture here, and in part 2, we'll see how to deal with the categorical features in our data frame, and we'll begin to actually build our decision tree and random forest model. Thanks everyone, and I'll see you in the next lecture.